Bismillah ar-Rahman ar-Rahim. We have integral x from 0 to 1 of log x cubed log 1 plus or minus x divided by 1 plus or minus x. We are interested in evaluating these four integrals. Let's start with this one. This integral was previously evaluated using Euler's sum. We are interested here in the special case where positive integer k is equal to 3. The outside factor is 3 factorial minus 1 to the 3 over 2. That's minus 3. Inside the bracket, we have this term. K is 3. So we have minus 4 times zeta of 5. We have a sum, v from 1 to k minus 1. We have two terms when v is equal to 1 and when v is equal to 2. The summand is zeta of 4 minus v times zeta of v plus 1. When v is 1, we have zeta of 3 times zeta of 2. When v is 2, we have zeta of 2 times zeta of 3. This sum is 2 times zeta of 2 times zeta of 3. The integral with a minus sign in the numerator and a minus sign in the denominator is 12 zeta of 5 minus 6 zeta of 2 times zeta of 3. Let's review this very useful result when dealing with logarithmic integrals. We have integral x from 0 to 1, x to the a log x to the b. Let's do the change of variables, x equal to e to the minus w over a plus 1. When x is 1, w is 0. When x tends to 0 from above, w tends to infinity. Dx is minus 1 over a plus 1, e to the minus w over a plus 1 dw. We can use this minus sign to have the integral from 0 to infinity. X to the a is e to the minus w times a over a plus 1. Here is dx without the minus sign. Log x is minus w over a plus 1. This is raised to the power b. We can take a plus 1 to the power b plus 1 outside the integral, also minus 1 to the power b. The product of these two exponentials is e to the minus w. The integrand is w to the b, e to the minus w. We have integral w from 0 to infinity. That's gamma of b plus 1. This integral is minus 1 to the b times gamma of b plus 1 divided by a plus 1 to the power b plus 1. Now we have the integral with a plus sign in the numerator and a minus sign in the denominator. Integral x from 0 to 1 log x cubed log 1 plus x over 1 minus x. We can write this integral as integral x from 0 to 1 log 1 plus x d integral u from 0 to x log u cubed divided by 1 minus u. We do integration by parts. When x is 0, we get 0. When x is equal to 1, this product is log 2 times the integral u from 0 to 1 log u cubed divided by 1 minus u. We write 1 over 1 minus u as summation over non-negative integer j of u to the power j. We interchange the order of summation and the integration. According to this result, we get minus 1 to the 3, that's minus 1, gamma of 4, which is 3 factorial or 6. This is divided by j plus 1 to the power 4. The sum is zeta of 4. This part is minus 6 log 2 zeta of 4. When we do integration by parts, we get this double integral, x from 0 to 1, this integral times the derivative of log 1 plus x, which is 1 over 1 plus x. We change variable u to variable t. U is tx, du is x dt. When u is 0, t is 0. When u is x, t is 1. With this minus sign, we get minus integral x from 0 to 1, t from 0 to 1, log tx cubed divided by 1 minus tx, x over 1 plus x. We can do partial fractions. This part is equal to 1 over 1 plus t times 1 minus tx minus 1 over 1 plus t, 1 plus x. We split into two double integrals. Let's start with this one. Log tx is log t plus log x. When this is cubed, we get these four terms. The variables t and x play symmetric roles in this double integral. We essentially have two double integrals. Integral t from 0 to 1 log t cubed over 1 plus t times integral x from 0 to 1 of 1 over 1 plus x. We multiply this by 2. We have integral t from 0 to 1 log t squared over 1 plus t times integral x from 0 to 1 log x over 1 plus x. This product is multiplied by 6. This integral is equal to log 2. So we have here 2 log 2 times the integral with respect to t. When alpha has a magnitude less than 1, 1 over 1 plus alpha is summation j from 0 to infinity minus alpha to the power j. We use this series representation to evaluate these three single integrals. We have 2 log 2 summation over non-negative integer j of minus 1 to the power j integral t from 0 to 1 t to the j log t cubed. From here we have 6 times the product of two sums. In the first sum we have j from 0 to infinity of minus 1 to the j integral t from 0 to 1 t to the j log t squared. In the second sum we have summation k from 0 to infinity minus 1 to the k integral x from 0 to 1 x to the k log x. This integral is minus 1 to the power 3 times gamma of 4. This is minus 6 divided by j plus 1 to the power 4. Here we have minus 1 squared times gamma of 3, that's 2, over j plus 1 cubed. For the integral with respect to x, we get minus 1 to the power 1, gamma of 2, that's minus 1, divided by k plus 1 squared. We have minus 12 log 2, summation j from 0 to infinity, minus 1 to the j over j plus 1 to the power 4, minus 12, summation j from 0 to infinity, minus 1 to the j over j plus 1 cubed, into summation k from 0 to infinity, minus 1 to the k over k plus 1 squared. If we don't have this term, this summation is zeta of 4. Because the terms are alternating in sign, we need to subtract double the sum of the reciprocals of the fourth powers of the positive even integers. This is 1 over 16 times zeta of 4. This sum is 14 over 16 or 7 over 8 times zeta of 4. This part is equal to minus 21 over 2 log 2 zeta of 4. We evaluate these two sums in a similar fashion. This is zeta of 3 times between brackets 1 minus 2 times 1 over 8. This sum is zeta of 2 between brackets 1 minus 2 times 1 over 4. This part is minus 9 over 2 zeta of 2 times zeta of 3. Now let's go back to this integral. Interchange the order of integration. Change variable x to variable u. U is equal to xt. When x is 0, u is 0. When x is 1, u is t. dx is du over t. In the denominator, we have the product t times 1 plus t. This is 1 over t minus 1 over 1 plus t. The antiderivative of this function of t is log t minus log 1 plus t. That's log t over 1 plus t. Let's do integration by parts. We have integral u from 0 to t, log u cubed over 1 minus u. This is multiplied by log t over 1 plus t. When t is equal to 1, we get log 2 times integral u from 0 to 1, log u cubed over 1 minus u. This is integral u from 0 to 1, log u cubed, summation j from 0 to infinity, u to the power j. We integrate term by term. We have log 2 summation over non-negative integer j of the integral u from 0 to 1, u to the j, log u cubed. This integral is minus 1 to the power 3 times 4 factorial. That's minus 6 divided by j plus 1 to the power 4. The result is minus 6 log 2 zeta of 4. We previously got this. Also minus 21 over 2 log 2 zeta of 4. If we sum, we get minus 45 over 2 log 2 zeta of 4. We need to take the limit of this product as t tends to 0 from above. This is log t minus log 1 plus t. Log 1 plus t into the integral will cause us no trouble. This is 0 as t tends to 0 from above. We need to be careful when the integral is multiplied by log t. As t tends to 0, the integral tends to 0, but log t tends to minus infinity. We can write this product as a ratio. The integral over 1 over log t. We have a 0 over 0 situation. We can apply L'Hopital's rule. In fact, we apply it a number of times and get a limit of 0. We are not done yet. When we do integration by parts, we also get plus integral t from 0 to 1 log t over 1 plus t. This is multiplied by the derivative of this function of t. The derivative is log t cubed divided by 1 minus t. Write the logarithm as a difference. This integral is equal to integral t from 0 to 1 log t to the power 4 over 1 minus t minus integral t from 0 to 1 log t cubed log 1 plus t over 1 minus t. This part is exactly minus capital I plus minus. This is the negative of the integral that we have on the left-hand side. What about this integral? It is evaluated like this one. We have summation over non-negative integer j, integral t from 0 to 1, t to the j, log t to the power 4. This is minus 1 to the power 4 times gamma of 5 divided by j plus 1 to the power 5. This integral is equal to 24 zeta of 5. The right-hand side is these three terms minus I plus minus. Move this to the left-hand side. Divide both sides by 2. We get that this integral, which is integral x from 0 to 1 log x cubed times log 1 plus x over 1 minus x. This integral is equal to 12 zeta of 5 minus 45 over 4 log 2 zeta of 4 minus 9 over 4 zeta of 2 times zeta of 3. The next integral to consider is I plus plus integral x from 0 to 1 log x cubed log 1 plus x over 1 plus x. Let's write 1 over 1 plus x as 1 minus 1 over 1 plus x. This is x over 1 plus x, so we need to divide by x. 1 over 1 plus x is 1 over x minus 1 over x times 1 plus x. Split into two integrals. Let's consider first the integral with 1 over x. The antiderivative of log x cubed over x is 1/4 times log x to the power 4. Do integration by parts. We get 0 when we use the limits of integration. This integral is equal to minus 1 over 4 log x to the power 4 times the derivative of log 1 plus x, which is 1 over 1 plus x. Use the series for 1 over 1 plus x and integrate term by term. the integral is minus 1 to the power 4 times gamma of 5, that's 24. In the denominator, we get j plus 1 to the power 5. This summation is zeta of 5. Between brackets, we have 1 minus 2 times 1 over 32. 15 over 16 times gamma of 5 times minus 1 over 4 is minus 45 over 8. Let's consider the integral with this part. Write the integral as an integral from 0 to infinity minus an integral from 1 to infinity. The integrand is log x cubed, log 1 plus x over x times 1 plus x. The integrand here is written using variable y. Now do the substitution, y equal to 1 over x. dy is minus 1 over x squared dx. When y tends to infinity, x tends to 0 from above. When y is 1, x is 1. We can use this minus sign to have the integral from 0 to 1. dy without the minus sign is dx over x squared. Replace each y here by 1 over x. In the denominator, we get x plus 1. Log y cubed is minus log x cubed. 1 plus y is 1 plus 1 over x. When we apply the logarithm, we get log 1 plus x minus log x. Split into two integrals. Integral x from 0 to 1. Log x cubed, log 1 plus x over 1 plus x. This is I plus plus. Minus integral x from 0 to 1. Log x to the power 4 over 1 plus x. Based on this result, this integral is minus 45 over 2 zeta of 5. I plus plus is equal to minus 45 over 8 zeta of 5 minus this integral over positive x minus I plus plus 45 over 2 zeta of 5. Move this to the left-hand side. We get the 2i plus plus is equal to 135 over 8 zeta of 5. This is what we get when we combine this term and that one. We also have minus this integral x from 0 to infinity log x cubed log 1 plus x over x times 1 plus x. Dividing both sides by 2, we get that I plus plus is 135 over 16 zeta of 5 minus 1/2 this integral. Do the change of variables, y equal to 1 over 1 plus x. X is minus 1 plus 1 over y. Dx is minus dy over y squared. When x is 0, y is 1. When x tends to infinity, y tends to 0 from above. With this minus sign, we get an integral from 0 to 1. Every x is replaced by 1 over y minus 1. Simplifying the integrand, we get integral y from 0 to 1, the cube of log 1 minus y minus log y, times log y over 1 minus y. Expand and split into 4 integrals. The expansion is log 1 minus y cubed, minus 3 log 1 minus y squared, log y, plus 3 log 1 minus y, times the square of log y, minus the cube of log y. Each of those terms is multiplied by log y over 1 minus y. This integral is I minus minus. We obtained it on the first page as 12 zeta of 5 minus 6 zeta of 2 times zeta of 3. In this integral, replace y by 1 minus y. We get integral y from 0 to 1 log 1 minus y, the cube of log y over y. The antiderivative of this part is 1/4 log y to the power 4. Do integration by parts. This is 0 when we use the limits of integration. We also get minus 1/4 integral y from 0 to 1 log y to the power 4 times the derivative of log 1 minus y, which is minus 1 over 1 minus y. In this integral, also replace y by 1 minus y. We get integral y from 0 to 1, the square of log 1 minus y, the square of log y over y. The antiderivative of this part is 1/3 times the cube of log y. We do integration by parts. This is 0 when we employ the limits of integration. We get minus 1/3 integral y from 0 to 1 log y cubed times the derivative of this function of y, which is 2 log 1 minus y times minus 1 over 1 minus y. This part is 2 over 3 times I minus minus. This integral is equal to this part plus this one multiplied by minus 3. That's minus 2 I minus minus. From here we get 3 I minus minus. Then this integral, we get I minus minus, minus 3 over 4, integral y from 0 to 1, log y to the power 4 over 1 minus y. Using the series and term by term integration, we get summation j from 0 to infinity, integral y from 0 to 1, y to the j, log y to the power 4. This is minus 1 to the power 4 times gamma of 5 over j plus 1 to the power 5. Gamma of 5 is 24. From here we have minus 18 times zeta of 5. And from I minus minus, we have 12 times zeta of 5. Combining the two terms, we get zeta of 5 multiplied by minus 6. We also have minus 6 times zeta of 2 times zeta of 3. I plus plus is this integral divided by 2 plus zeta of 5 times 135 over 16. Combining these two terms, I plus plus is 87 over 16 zeta of 5 minus 3 times zeta of 2 zeta of 3. We obtained I minus minus and I plus minus on the first page, I plus plus on the second page. The last task is to evaluate I minus plus. We do so by establishing a relationship between the four integrals. We already know 3 of them, so we can get our target integral. Specifically, we add I minus minus and I plus minus. When we combine the integrands, we get log 1 minus x squared over 1 minus x. The numerator here is log 1 minus x plus log 1 plus x. We subtract the sum of I plus plus and I minus plus. When combined, the integrand of this sum is log x cubed times log 1 minus x squared over 1 plus x. Now combine these two terms. We get integral x from 0 to 1 log x cubed log 1 minus x squared times 2x over 1 minus x squared. Let's do the change of variables. Y equal to x squared. X is the square root of y. Log x is 1/2 log y. We get 1/8 times the cube of log y. The ratio log 1 minus x squared over 1 minus x squared becomes log 1 minus y over 1 minus y. 2x dx is dy. On the right hand side, we get I minus minus divided by 8. This means that our integral of interest is this particular linear combination of the other 3 integrals. Simplifying, we get I minus plus in terms of zeta of 4, zeta of 5, and the product of zeta of 2 and zeta of 3. Here is a summary of our results.